All right, here we go. Welcome back from Pensacola, everybody, and I hope you had a good trip. We're going to go over a couple things real quick, and I know you guys like my drawing, so I didn't want to not record that part of it. I was so good at drawing, you know. And so we have A and B there, and we have this one coming from C, so there's A, B, C. This is D, and then we have R, P, Q, and then from here it goes up to this is the middle, and that's O, and then it goes straight down, and this is C here, and we've got C, and this is X, and this is a right angle, and then there. So now is our drawing. We got our drawing. Everybody see it? Perfect. Awesome. Now, first question: name the center of the circle. Joseph, you do the homework? Yeah, you did. You did it in that class that I came to, but you weren't here. Oh, you know what? I didn't come, and you just did it yourself. Good. All right, 0. Good. Name the radiuses. There are 2 radiuses in this one. It is Nathan. Nate. Wake up back there. 0C and OQ. Very good. All right, name the chords. There are 3 chords. Amber. RB, good. RP, yep. And PQ, good. All right, wonderful. Name a secant line. Name a secant. Now remember what is a secant line? It touches this thing how many times? 2 times, 2 times. So secant is the AB, very good. And what is a tangent line? It touches it once, it's CD, very good. Well done. All right, CD. Now, find angle OC, okay, and COQ. COQ. What angle is that? Somebody help me out with that. And the angle is 90 degrees. Well done. Good. 90 degrees. All right, good. If PQ, so we're talking about PQ, this angle here, is 12. So the whole thing is 12. What is XQ? Well, now, remember, we talked about it. If it's a right angle and it's perpendicular, then what does it do to the chord? It bisects the chord. What theorem is that? 9.1. Good. Awesome. All right, so if it's 12, then half of it is Maddie. Oh, Maddie, you're gone. I remember. Maddie, I hope you're having a great trip to Florida. You and Connor enjoying yourselves down there. Hope you don't miss me too much. And then the answer is 6, though. 6. Very good. All right. Name a central angle. Now, there's one central angle here, and it goes through the middle. So what is it? QOC. QONC. All right. QOC. Any questions? Wonderful. Next. Name an inscribed angle. Inscribed. So an inscribed angle says where does it start? On the circle. So an inscribed angle is BRP. Here's another one. It is RPQ. All right. Another one can be this one. ABR. Okay. So as long as the vertex is on the circle and it goes to the other side, that's a inscribed angle. Good job. All right. Well done. Now, name if OQ, if this is 26, if that is 26, now remember, what is OQ? In this drawing, it is a radius. Good job, Josh. So if that's a radius, what is OC? Well, OC is a radius. So if this radius is 26, what's this radius? The answer is what? 26. Wonderful. So does everybody have any questions on that homework problem? So that's 1 through 10. 1 through 10. You can have Mrs. Scala look at the book for you if you missed any of the questions I gave. But that's 1 through 10. We did them together in class. Now you know a little bit better about them. Now, let's move on. Let's do number 13. We're going to skip number 11. I'm not going to do that one on the board, but we'll do number 13 on the board together, and then we're going to go to the other problems. So hopefully we can get all this done, and you can watch this video through, get all the answers right. If you need to watch part of it again, go back to the YouTube channel, watch it again. I know you'll miss me, so this is a way that you can kind of feel like I'm still with you. I mean, I care about you, but I just want to sit in the sun for a little bit. All right? Okay? All right, so here we go. All right, so number 13. All right, so here's our drawing, a circle. And we have two, from there we have 2. Okay, then go A, this point's B, this point C. We have this line goes in here to the middle, and it's intersecting at, this is not at the center, so we got to go like this a little bit. That X is the center. B. Okay, so everybody see the drawing? The given AB and AC are tangents. So that means they touch how many times? Once. Good. AX bisects BAC. So we need we're trying to prove BDA is 90. So we're trying to prove that this angle here, that's 90 degrees. That's what we're trying to prove. Okay, so that's a little difficult, I understand, but let's see how we do. So we'll start. So how can we do that? If we can prove that this is 90, or if we can prove these two are congruent, then they're 180 degrees, they're equal, that means they're going to be 90 degrees. So if we can prove that they're 180 degrees and that they're congruent, that helps. So how do we prove congruency? Well, we can prove triangles are congruent. So has everybody got that? Everybody can say that we can prove that our triangles are congruent. If we can prove triangles are congruent, then what can we prove? What can we prove? That they are what? Equal. Then they're equal to 180. We know that because you can see that there's a straight line, so that's 180, and then that divided by 2 is 90, and therefore we got our answer. So let's prove that these triangles are congruent. So first off, AX, so this line, bisects BAC. So when something bisects it, we know that angle, so let's put numbers here, 1 and 2. Angle 1, congruent to angle 2, why? Definition of angle bisector. When something is bisected, it makes them congruent. So we now have these angles being congruent. What else do we see that is going to be the same in both triangles? The same in both triangles is going to be what? AD. Well done. So AD is congruent to AD. Reflexive. Okay? So far, in our triangles, in our two triangles, what do we have? We have what? A congruent angle and a congruent side. What can we do now? What do we know? What are some theorems that we learned in this chapter? One of the theorems we learned in this chapter was that if it's 90 degrees, it bisects it. Well, do we see a 90 degree? We don't know that, so we can't say that. What else did we learn? 9.2, 9.3, those are theorems. Yes, I understand that, but do they help us in this passage? No, because they're saying they're equidistant from the center, then they're congruent, there's two different chords. That doesn't help us. 9.4 doesn't help us either, because 9.4 does what? You remember what 9.4 was? A 9.5. 9.4 and 9.6. They flipped each other, and they were talking about what? Once we go back to our problems, make sure you got it right here. 9.4 and 9.6. They talked about if they were perpendicular, then they were tangent. Perpendicular, then they were tangent. So that doesn't help us here. But 9.7 does, because what does 9.7 say? If two lines are tangent to the same exterior, then what did you know about those? They were what? They were equal, or they were congruent. So AB is equal to AC. Well, why is that? Because they're 9.7. So, class, if they're equal, then they're what? They're congruent. Thank you. Definition of congruent. So, class, are my triangles congruent? Yes, they are. Joseph, why are my triangles congruent? Triangle BDA is congruent to CDA. Why? side, angle, side. So, if my triangles are congruent, what do I know about? Let's make these 3 and 4. Angle 3 is congruent to angle 4, CP, CTC. Good job. CP, CTC. Now, if those are congruent, okay, so now what's next? We're almost done. All right, if they're congruent to each other, then what do we know? They are what? Linear pairs are supplements. Okay, so we have to say this is a linear pair. So BDC, so what we say is they're supplements. So angle 3 and angle 4 are supplements. So what does that mean? They're equal to 180 degrees. Okay? That's linear pairs, so it's a linear pair. See how it's aligned? Linear pairs are supplements. By the way, that is 4.3. Linear pairs are supplement. Now, last step. If they're supplementary, what do they equal? 180. Well, remember what I said. If they're supplementary, then they are what? They are 90 degrees. They're right angles. So, angle 3 and angle 4 are right angles. Why are they right angles? Because in chapter 6, we talked about supplements are what? What did we learn? Or I'm sorry, in chapter 4, we learned this, is that a right angle, if congruent supplements are right angles. So, angle 3 is equal to, which is BADA, to 90, because definition of a right angle. I'll turn it down there. You see that? Angle 3 equals 90, definition of right angle. So angle 3 is technically BDA. And that's your answer. Okay? So very important that you follow this and that you know how to do this problem. So if you need to, stop the video, make sure you get all the information, and then we will move on to another problem. Okay?